We'll start here, case 6 and case 7 together. Actually, this is just case 6. I will correct it. It is a case 6 because whenever we come across this situation that all three angles given, you will observe here triple A or ASA. So triple A and ASA is given. We generally use a polar triangle. We'll discuss about what are the polar triangles. It is not like in our multiple integral we convert from Cartesian to polar. That polar is a different and this one is a different. Okay, we don't have to go in some other domain. Nothing like that. Yes, but we are shifting our problem from one triangle to the other triangle, and that triangle is a polar triangle. How we construct the polar triangle and what is a polar triangle, let we discuss here. So in which case mainly we are using this polar triangle. This is a triple A, all three angles given or angle side angle is given. Okay, so already we discussed about spherical triangle. So what is spherical triangle in this figure? In the figure, which one is the spherical triangle?
AB.
This triangle ABC, is it? And that is made up of three intersection of the three great circle, is it? Now,
Yes, sir.
as the name suggests, this polar triangle. So every spherical triangle have its a primitive. Okay, it's a primitive, and that primitive triangle can be obtained by the poles of the great circle. For example, this AC is the smallest arc or smaller arc of that one of the great circle there. That great circle you observe that is shown by dotted. So for this AC, for this arc AC, there will be the two poles, is it? For every great circle, there are two poles which are equidistant from that. So let me assume for this great circle, somewhere here we have for as it is a side AC, I denote it by B dash. I taken this point as a B dash here. Okay. So there is one B dash point. Now, similarly, for the great circle BC, you will observe this side or that side. You can take any one side there. We have one of the pole, and that one of the pole that I denoted by, say, this is the A dash. And lastly, we have this side AB. For this side AB, we have one of the great circle that is a C dash. So let we say this is a C dash. So right now we have 3 points A dash, B dash and C dash. So if we draw a great circle passing through these 2 points, like suppose this A dash C dash is arc of one of the great circle, B dash C dash is arc of another great circle, and A dash B dash is the arc of another great circle. So we have 3 great circles again passing through this points A dash, B dash and C dash. This triangle A dash, B dash and C dash is known as a polar triangle or a primitive of the triangle ABC. Is that clear? Any doubt what is a polar triangle?
No, sir.
Okay. So nowhere you have to draw these diagrams. Remember, this is just for your information. Actually, for a given triangle ABC, we can take the poles of that sides of the triangle, and we join that poles of the sides of the triangle. We get a primitive triangle or a polar triangle there. So in this case, suppose we are given this ABC as a given triangle. Okay, and in this triangle we are given all the three angles. So how we approach this problem? Remember, only step 1 is important. Remaining you already done that. Okay, so it is very simple, even though it looks complicated. So in the next thing, we have to use a supplemental theorem. What is this supplemental theorem? Supplemental theorem that two angles are supplement of each other. Actually, you know already the complement. Complement angle means their sum is a 90 degree, is it?
Yes, sir.
Complement means sum is a 90 degree. Here supplement angle means their sum is a 180 degree. Okay, when the sum of the angles is a 180 degree, they are supplement angle. So it is already we will take it right now without proof here, but yes, we can prove that also with geometry that the angle A and the side A dash, the angle A and side A dash of the original triangle and the primitive triangle, or original triangle and polar triangle, is always 180 degree. So we can write these equations like A plus A dash, A plus A dash is 180 degree, B plus B dash is 180 degree, C plus C dash is equal to 180 degree. Not only this, we can have three more equations. Say uh, A, this A plus A dash is 180 degree, B plus B dash is 180 degree, and lastly C plus C dash is 180 degree. So all these are the things, or these are the relations by the supplement theorem there. Okay, so angle and side of the primitive is always a 180 degree, so that you can remember the primitive of a primitive. When you take primitive of a primitive, you get again original triangle only. Okay, for example, we seen that A dash B dash C dash is a new triangle we get, that is a polar triangle. But suppose A dash B dash C dash, for A dash B dash and C dash we find out their poles again, we get the poles as ABC only, we'll get ABC only, and we get that primitive of a primitive, again original spherical triangle there. So this is only the new part for you. This 6 formulas is only new to you. What happens now? What happens? See, capital ABC is known to us. So this capital A is given, capital B is given, capital C is given. So indirectly, now we know we have the values of A dash, B dash and C dash. And what are these small A dash, B dash, C dash? What they represent?
Side.
Side of the
Side.
polar triangle. Yes, correct. They are side of the polar triangle. Now, if we know all the three sides of the polar triangle, can we solve the problem? Yes, anyone?
Yes, sir.
So, by which rule? When all three sides are known to us, which rule we use?
Sine formula.
Pardon?
Cosine rule.
Cosine rule is the correct answer. Sine rule you cannot. You cannot use a cosine rule because all three sides only known. For using a sine rule, we should have at least one pair of side and its opposite angle. Okay. So either we use a cosine rule or Haber sign, but I prefer generally the cosine rule, and we can solve that problem. So what is the meaning of that? With the help of these sides of the polar triangle A dash, B dash, C dash, we can easily calculate capital A dash, capital B dash and capital C dash, which are by the cosine rule. Once we get that capital A dash, B dash, C dash, and if our aim is to get the values of this capital A, B, C, what should be done? Sorry, this capital ABC is given. If our aim is to get the small ABC, sorry. Yes.
Cos A dash is equal to cos
No.
capital A dash.
Okay. No, you are giving me the formula. I'm not interested in formula right now. My question is, yes, I know when you have all the three from this angles from the capital ABC, we got three sides of the triangle. From the three sides of the triangle, suppose we calculated capital A dash, capital B dash and capital C dash. That is now available to us. But our aim is to get final answer as A, B, C. So how to get small a, b, c with the help of these capital A dash, B dash, C dash? Supplemental theorem. That's correct answer, and that is only here on the screen. You will observe small ABC, and this is the relations. We can use it, and we can get this small ABC there. So we have to use 2 times supplemental theorem so that we get the answer in the given domain only. Okay. So let I show you a theory, and then we'll see the example. Then becomes more clear again. So supplemental theorems. This is another way of drawing the diagram. So one way that ABC I drawn and A dash, B dash, C dash also I drawn. Or you can draw the diagram like this. You draw one ABC here, like this is say A, B, C. and this another triangle, say A dash, B dash, C dash. You can draw it separately also. You can draw one in other, like A, B, C, and this A dash, B dash, C dash, or this way also. Okay, that is way of writing the drawing the different ways of drawing the diagram there. So all are correct. So once our problem is converted to the triple S, means all three sides, or side angle side form, we use a cosine rule and we solve that problem. Okay, that's one. Come to the question now. Tell me which three quantities given?
Angle.
And all the three angles are given.
All the three angles given, and we have to find out all three sides there. So whenever triple A is given or SAS is given, we have to use the polar triangle that we already know. So use a polar triangle. So this is a capital PQR given. So we get a new triangle, say P dash, Q dash, and R dash. Now these values are also written. How we got the value of P dash? Yes, anyone?
180 minus.
180 minus P.
180 minus this small p, correct. So 180 minus 57, you will get this one. Then 180 minus capital Q, this gives 84, and 180 minus 70, you get that one. So by supplemental theorem, you will observe we get the values of P dash, Q dash, and R dash first. Now all three sides are known. So which formula?
Cosine.
Cosine. Tell me first which formula you will use out in that cosine. You will calculate which quantity.
Cos of P dash.
Cos of P dash. Okay, good. Small p dash or capital P dash?
A small p
Small.
dash.
Small z.
Small p dash. Okay, let's consider this as small then. Okay. Cos of p dash is equal to,
Cos of capital P dash
okay,
into sine of R dash into sine of Q dash plus cos of R dash into cos of Q dash.
okay. Yes, good. So that's a formula we can use. Just replace the angles, and we should get with this formula. With this formula, we will get the value of this uh, capital P dash. Once we get capital P dash, what should be done? Suppose this capital P dash is alpha, then we have again supplemental theorem to get the value of a P. By supplemental theorem, and you get 180 minus alpha as the answer. So let I show you the answer there. So I given directly, there are too many things that you have to do it there. Already we discussed about one of the thing only, just for calculation of P dash. Similarly, you can proceed for others also. And you should remember what I discussed at the beginning. One problem can be solved in multiple ways. So right now, if you've done one calculation, suppose you've done one calculation by a polar triangle, and suppose you got P dash. Now the quantities which are available is capital P dash is available, this side, and this side is available. Then when you get capital P dash, when you get from capital P dash, when you get a small p, so my mistake, small p. So actually you can see in the original triangle small p is available. Okay, and our aim is to get that small q and small r. So to do the calculation of this small r and q, we require actually that capital R dash and q dash. That is one of the way you can move by a polar. What is the simplest way? Yes, anyone? What is the other way to get the value of r and q once you get the value of a small p? So the small p is available now to you. Small p is available and you have to compute r and q. Yes. No one is thinking of the problem, huh? We learned different methods. See, all these PQR can be calculated by cosine formula only. That is one way. But I will tell you there is another simple way also. Cosine is also, itself a simple. That is also okay. But you can use, see, you have the angle, you have the opposite side. Then and you have to find out and capital Q is also there, and you have to find. So you can use sine rule also. Is that? But sine rule creates ambiguity, and you have to solve that. Any doubt, anyone? No doubts. Okay, that's okay. Good then. Okay, so I'll move to last formula here. This calculation, yes, you can do it in tutorial mainly, and I will cross check whether you are able to do that calculations or not. Okay, so here these are the final answers. So 2 times supplemental theorem is used. First supplemental theorem converted triple A problem into triple S problem, and triple S problem solved by cosine formula. And after cosine formula, again this is a supplemental theorem. Again supplemental theorem is used. And we get the solution of original problem that way. So these are the steps that we are doing when for the polar triangles mainly. Here is the last formula that for you in our syllabus. We have cotangent four-part formula. Okay. When we use this formula is mainly used whenever, just a minute. This formula mainly we used whenever in 4 consecutive parts, if one of the inner part is missing. But I will tell you, unless it is mentioned in the question that solve the following problem by cotangent 4-part formula, no need to go to the cotangent. All these problems can be solved by a sine rule also. Is it? Because see, in 4 consecutive parts, means if you take any triangle, say this triangle ABC. So in triangle ABC, we have to write down the consecutive parts. If we started with say angle A, if we start with angle A, then after angle A, you can move clockwise or anti-clockwise. Let I move clockwise here. So capital A, small c, then capital B, then small a, then capital C, small b. So we started this clockwise way. So there are all these 6 components written, these written in a consecutive form. So A, C, B, A, C, A. So these are consecutive components. So out of these 6, we are given one of the sequence only. It may be like B to small b, like capital B, A, C, B, that way, or A to small a, or the small c to capital C, that way. So let I assume we are out of these 4 missing components. Out of these 4 components, the missing component is small c. The small c is missing. Here it is written. Small c is missing. This given, and this given. So 4 consecutive part. So we can use here cotangent 4-part formula to solve the problem. What is the other way I said? What is the other way to solve this problem? Yes, anyone?
Sine rule.
Sine rule is only there. Okay, because you already observed here this angle and opposite side is given. Angle and opposite side is given, and can we use the sine rule? Yes. But to you see that become little lengthy. If you have to use a sine rule, it becomes little lengthy. With the help of this, actually, first you have to calculate small b. Small b you can get it because this capital B is given. Small b you can calculate, and then you have to decide again because sine rule will not work directly. Sine rule will not work directly to get a small c there. Is that so? If you want to go with the sine rule, from capital B you can get a small b, and after that now you can decide that small c and capital C both are unknown to us, so you can use a cosine rule. You can use a cosine rule or only cosine rule there, I think. Okay, so that way you can proceed. So multiple ways are there to solve the problem, but the answers are unique. We'll come to that part also, how answers are unique. And first write all 6 triangle parts in cyclic order. So this will be the order, and out of this, suppose in any 4 consecutive parts, say this one or this one, few components given like C, B, and so already we discussed about the case 1. So outer parts are when this sequence is there, this capital A and small a is outer parts, and out of these outer parts, only inner part should be missing. One of the inner parts should be missing. So either C or capital B is not given, then only we can use a cotangent formula. This cotangent formula is this one: cos of inner side into cos of inner angle is equal to cot of outer side into sine of inner side minus cot of outer angle into sine of inner angle. Okay, that formula is only there. Otherwise, nothing new. So can you tell me? Suppose this is our set. This is our set. So in this set, can you tell me the formula, cotangent formula? Tell me the cotangent formula for this sequence. Quick.
Cos C.
Okay, good. Cos of C into cos of B, is it equal to cot of outer side? So it is outer side here.
Cot of
A.
Cos of A is correct. Into sine of inner side.
sure. Cot of
Cot of A.
Sorry, cot of A. My mistake.
okay.
Sine of inner side.
C.
Yes.
P.
Cos of
Minus
C.
cot of outer angle.
Capital A.
Correct. Into sine of inner angle.
B. Capital B.
That's one. So this is the formula we created. Now out of this formula, say this small c is given. So sorry, small c only we have to find out. This we have to find out. So capital A, capital B given. So this we can get it. This also we can get it. Capital A, capital B both are given. Then small a is given. These calculations we can do it. Cos C upon sin C can be considered later on as a tan C something, and we can solve it there. Okay, so that way we have to approach to a problem. So just replace the values, do a calculation, take an inverse. If sine appears there, you will get 2 different angles, theta and 180 minus theta, and we have to solve that ambiguity there. Okay, which angle should be the answer there? I have not taken any example of cotangent here. Okay, cotangent, I think in last 4-5 years only once it is asked, like solved by, but okay, you can. I not given. I think probably I also not given this example on cotangent in tutorial also. But if you want, yes, later on we'll take one of the example at the time of discussion of the tutorial examples there. Okay, so that about the uh, this is the formula that we have. So again, recap here. So what you learned actually throughout this spherical trigonometry. In spherical trigonometry, first we'll just see in the introduction few definitions like what are the poles, great circle, radius of the great circle, hemisphere. Okay, so these things as a prerequisite of spherical trigonometry, and then we learned all these different methods. But I will tell you, you should approach to the problem this way only. Whenever you are given, suppose a right angle triangle or a quadrantal triangle, better to start with an Napier's rule. This is the simplest rule that we have. Because of that, we are giving the preference to this. So many times this question can be solved by cosine rule and Haversine rule also. But best is a Napier's rule for right angle and quadrantal. Quickly you get the answer. Then triple S and SAS. Okay, three sides. So we use a cosine rule then. Okay. Third case, triple and ASF. Yes, we use a polar triangle plus cosine rule, cosine or sine rule there. Lastly, this out of, okay, this is sine rule, we use it. This sine is also one of the important. Polar is important. That's one. Cotangent is generally, whenever it is mentioned, then only you can use it. Otherwise, most of the problems you can solve by these four rules only: Napier's rule, cosine rule, sine rule, and polar triangle. That's all. Okay. So that about your end of this spherical trigonometry. But not only this, I want to show you one more part here. Yesterday, one of the student asked that question. Anyone thought on that? Anyone thought on that problem? That is it possible? Yes or no? Yes, correct.
Yes.
Just 1 minute. First, there is a question from Tushar. He says cotangent is not given in a book which has been provided to us. Yes, cotangent is actually repetition. This is a repeated method. We can say it is optional method. Because of that, it is not given. Already, I told that all the problems can be solved by the previous up to polar triangle only. This cotangent method is one of the extra method that you have to solve the problem there. Okay. Okay, Tushar.
Yes, sir.
Okay. So someone said yes for that. If all three angles are 90-degree and the triangle should be equilateral, is it possible? Yes or no? Quick. All three angles 90-degree as well as sides 90-degree. Sorry, not sides. Sides equal. Is it possible? Or let I ask that question again. All three angles 90-degree and all three sides 90-degree. Is it possible? A spherical triangle having all six component
Yes,
90-degree.
sir.
Yes is the correct answer. See, this is a online spherical triangle calculator which gives you directly answers. Okay. Even though you have these direct answers, you have to show by formula in the exam. Remember. For example, here is a question that I selected degree only. I'm entering all the values in degree. Suppose angle A is a 90-degree. This is side AB. This angle B is also 90-degree. Angle C is a 90-degree. And we just say calculate now. If you say calculate, you will observe there is only one solution to this problem, and we get all 90s there, all 90s. So when all three angles are 90-degree, all three sides are also up 90-degree. Okay, all three sides are up 90-degree, and we get a unique solution to that problem. That triangle is an equilateral triangle as well as, okay, you will observe obviously it is equilateral, means all three angles are equal also. But sum of the three angles of this triangle is 270-degree because it is not a plane triangle. Got it? you can see one more thing to these problems. Suppose you have this question. Okay, you have this question. Capital P, capital Q, and capital R given, and the question is find small pqr. So 57 degree 30.5 minute, that we have to enter. So generally I prefer degree mode only. So what I will do it, I will convert this capital P only in the degree. So to convert only in the degree, I will do it like this. 50 7 degree button, 30.5 minute, and then equal, and then I will take shift and then same button. I get 57.51 degree. So what is that angle? But now you see the notations are like capital PQR. So let me assume capital P is A, B, C, that way. So capital P is nothing but it is capital A, and capital A I can replace here 57.51. 57.51. Sorry, it is not entered. 57.51. Okay, so that is a capital P. This is one value we have. Next, capital Q. Capital Q is a 95 degree 17 minutes. 95 degree 17 minute, and I will take shift that button. 95.28. 95.28. 95.28. If anyone have doubt, yes, you can ask me here. And the third, 7011. 7011. 70.18. Good. This is a 70.18. So this is just, we entered all three angles. Now we have to calculate. Now we have to solve this problem. So I said calculate, and you observed we got a unique solution again. Only one solution we got, and that answers are 69.82 degree. Okay, 57.31 degree and 83.48 degree. See, the first answer is 69.82. 69.82. So it may be this R, 69.82 degree. Okay, so which becomes 69 into 50 minute. You can cross check also. This is 69.828. 69, sorry, 69.828 degree, and we want this in the, so 69 degree 49 minute 40 second. So that is I'm getting on calculator 69 degree 49 minute 40 seconds. So that answer also you can write it, or you can write the answer only like 69.828 degree also. Similarly you can get this another 57.31. you will observe 57.31. This is the small p, and lastly you have 83.48, and this 83 point, that is a small q there. Is that clear how to get a solution? This is just for cross checking purpose. I am saying you can use this calculator to cross check your answers if you want. There is no need to cross check if you are confident there. Otherwise you are wasting your time on doing this unnecessary calculation there. If we enter the values of this triangle, but remember, if you enter the values of this triangle, that capital LMN, okay, so sorry, capital M, capital L and small m, this calculator gives you the two solution there, solution 1, solution 2. Both solution will be shown by a calculator there. Okay, so that about your spherical trigonometry topic. The topic is a really simple. You can easily get 22 to 23 marks on this topic. Only the requirement is you should complete that one tutorial. If you do one tutorial, definitely you will get a very good confidence to do these questions in the exam also. Okay, so any doubt anyone here?